Loops inside loops, the secret to creating 2D patterns. Today we're mastering nested loops, the technique that puts one loop inside another. We'll understand exactly how they work, see their execution flow, and use them to create amazing 2D patterns. Let's start with the big idea. A nested loop is simply a loop inside another loop. Think of it like a clock. The minute hand completes a full circle for each hour, the hour hand moves. Here's our first nested loop in action. We're creating a 3x4 classroom seating chart. See how we have one loop for rows and another loop inside it for seats? The outer loop handles rows, the inner loop handles seats in each row. And this is what we get. Notice the pattern. For each row, all 4 seats are printed. The inner loop completes completely before the outer loop moves to the next row. Let me show you exactly how this works. Look at this execution flow diagram. The numbers show you the order. Steps 1 through 4 complete the first row. Then steps 5 through 8 do the second row. And finally, steps 9 through 12 finish the third row. Here's the critical rule you must remember. The inner loop always completes all its iterations before the outer loop moves to its next value. It's like finishing all your homework for one subject before starting the next. A nested loop with range 3 and range 4 creates exactly 12 total steps. That's 3 times 4. The multiplication happens automatically. This leads us to our multiplication rule. When you have nested loops with range m and range n, the code inside runs m times n total iterations. In our example, that's 3 rows times 4 seats equals 12 total steps. Quick challenge time. Look at this code. How many times will hello print? Remember our multiplication rule and think it through. Exactly. It's 6 times because 2 times 3 equals 6. The outer loop runs twice, and for each of those times, the inner loop prints hello 3 times. Incredible work! You now understand nested loops, loops inside other loops. Remember, the inner loop always completes before the outer advances, and total iterations equal outer times inner. Next up, we'll learn amazing visualization techniques,